Good morning, guys. Sorry for the delay. My internet was acting up. That's why. And you guys were really waiting patiently. That's great. So we'll finish this chapter, the cross product today, and we'll start chapter 14 next week. And as you have seen it, actually, I ask you to turn in your chapter 12 uh, lecture note homework and 13 next week. I just spread it such a way you will not be under pressure, and we will have our first quiz next week, next Friday, and that will be covering chapter 12 and 13. So you have a fair amount of actually heads up, and that will hopefully will work for everyone. All right, now let us work on vector. So let me remind you, I have a summary note prepared here, and then there is one topic that we didn't cover, that is really finding the torque. We'll talk about it, and then that will conclude. Okay, we learn about vector. Vectors are actually uh, mathematical concepts that represent physical quantities which has both magnitude and direction. And you have plenty of examples of vector, such as displacement, velocity, acceleration, force, uh, magnetic field, electric field, and so on and so forth. So you can add, subtract, multiply vectors. So when we are multiplying vectors, we can multiply a vector by a scalar and we'll get a vector. We can multiply a vector by a vector and we get the scalar, which is the dot product or scalar product of two vectors. And the third one that we are working is the cross product of two vectors, and it will give us the vector. Okay, the cross product of two vectors u and v with theta being in the angle between them, which is which can be from 0 degree up to a straight line, pi. Then the cross product of uv, as you know, is the norm of u times the norm of v times the angle of sine theta. And all these are scalar. So to find it's a vector, so we have to have a unit vector in the direction of that which is pointing, and n stands for the unit normal, where n is a unit normal vector, and the direction mutually orthogonal to perpendicular to both u and v. Well, how do I get actually unit vector? Well, if you have a vector, by normalizing it, you get a unit normal vector. Okay. Further note that any two vectors that are not parallel determine a plane. If two vectors are parallel, then actually we cannot really say much about it, because one is a scalar multiple of the other, so we cannot really determine. So the cross product, therefore, find a vector that is perpendicular to the plane. Oh, because n is a unit vector in the magnitude, and the magnitude of u cross v. So we can really find that very easily by normalizing. Okay. Two vectors u and v are parallel if and only if the cross product of the two is equal to 0, because sine of 0 is 0. Although these lengths are not 0, so sine of 0 is 0, so if they are parallel, it is 0. And note that since any vector u is parallel to itself, that means u cross u is always 0 for any vector. And the other thing that you have to know is vector cross product is not commutative. So v cross u is not the same as u cross v. Instead, v cross u equals the opposite of u cross v. properties of cross product actually will give you already, and it is in your textbook. All right, based on this, can you really find the cross product of this? Fill it up, please. So this is simple practice. What is I cross I, J cross J, K cross K, I cross J, and J cross K, and K cross I, and J cross I, and lastly K cross J.
Could you scoot the paper down a bit, please?
Okay. Actually, what about now? Is it readable?
Yes, thank you.
Okay, good. So what is this vector equals, guys? I cross I.
Zero.
All right. J cross J.
Zero vector, technically.
And this one also zero. Why? Because the cross product of parallel vectors is really zero. Therefore, the vector is parallel to itself with a scale factor of 1. Therefore, we have zero vectors in all of that. All right. So what is I cross J, guys? You have to use your right hand rule, and that is what? Is it K?
Yes.
Okay. How about then J cross K?
Negative I.
J you have, and you are crossing it with K. So you are going in counterclockwise direction. That is what? That is I. What about K cross I? So
Okay.
you start with K and you go counterclockwise. That is actually a J. All right. And what is J cross I?
Negative K.
Okay, negative K. And what is K cross J?
Negative I.
Negative I. Very good. And very simple way of for you to remember is actually, if you see, I gave you this picture last time, and set it up. I on the top, and on the left side J, and then K. And then when you are moving counterclockwise in this direction, it is positive, but when you are moving clockwise, it is negative. That is really a reminder for you guys. And this is really important. You might say, okay, why he bring it up second time? You might say, we are going to deal with the orientation and the direction later. Okay, we'll use actually determinant to find the cross product of vectors that are given in component form. And here it is. And I am not going to go through the discussion. Actually, using the determinant, you guys can come up with that. All right. Then, if that is what I'm going to ask you to do is actually forget number 9, but do number 10. Find a vector perpendicular to the plane that includes the point P, which has 1, -1, 0, Q, 2, 1, and -1, and R, -1, 1, 2. What is the area of the triangle formed by these 3 points? And find a unit vector that is perpendicular to the plane that includes these points. This is a vector called the unit normal vector to the plane. So I want to do this. Example 10. You have these 3 points. I want to find the cross product first, and then once you find what will be the area of a triangle. Suppose, of course, 3 points determine area. And lastly, what will be the unit normal of this vector of the cross product that you find in part A? Okay, always when you are working with given points, just randomly close those points, just like I did. Point P here, Q, and R. It doesn't have to be necessarily actually exact location. It will take up time. But as long as you have this is your reference and you can really come up. So, for example, my vector PR, let me call it U, that will be in the direction from terminal point, I subtract the tail, that means -1 minus 1, which is -2, and 1 minus -1, which is 2, and the 2 minus 0 is 2. And then PQ, which is my vector V, 2 minus 1 is 1, and 1 minus -1 is 2, and -1 minus 0 is -1. So the cross product of these two vectors is really calculating this. You guys come up with the same? It can be different. For example, you can start this Q, your starting point, and your vector will be this, and it might have a really different orientation, but it will be almost the same. But the main thing is, please have one point that the vectors are going to be originated from. And that's the main thing. Anybody who gets similar to this? Okay, anyone who gets different?
I got similar.
Okay. Yeah, even if it is different, don't really mess it up. The end result is going to be the same. And let us do. You work with your own, and I will work with this one also. All right. So the first vector that we are going to get with the I component 2 times -1, which is -2, and minus 2 times 2, which is 4. And the I component minus, and the j is -2 times -1, which is 2, and minus 1 times 2 is 2. All right, here I have 2, and here I have 2, and I'm subtracting, and the last one k, and when we are doing this is -4 minus 2. Okay, so we end up getting -6i and minus 6k. Yeah, because the j component is really 0. Is it clear, guys? Okay, good. Then now this is really what we get. Then now, what is the area of a triangle? If we are forming this one, it is area of a triangle. That means it is half of a area of a parallelogram. That means area equals 1/2 times the magnitude of u cross v. And that is 1/2 of the square root of -6 squared plus -6 squared, and that is actually 6 radical of 2 over 2, and that is the area. And now we are asked to find the unit normal, because if you see this vector is actually in the direction of the orientation is showing you this one, but can we make it a unit vector? Well, the unit vector or the unit normal is going to be u cross v divided by the magnitude of u cross v. That is what we are going to do. And as you know, this one has a magnitude of 6 square root of 2. So this is going to be -6. Let me write it in a component form, and say -6, and this is divided by 6 square root of 2, and that is it. We answered all that. All right, so this looks like actually what we are expected to work on, and I will give you one more practice of cross product, which is similar to your homework questions, and I'm sure you can handle this. All right, here it is. Find an equation of the plane passing through the point 1, 6, 4, and containing the line defined by R, which is given by parametrically 1 or vector form in the component 1 plus 2t, 2 minus 3t, and 3 minus t. So again, as I told you, try to draw your imaginative whatever. And let us assume this line is going like this one. This is line L. I'm not really drawing perfectly, just having visual reference. And then now I have a point 1, 6, 4. Let us assume this is point P. And then now, can you really come up with the equation of the plane that is containing this point and the line? In other words, what is the equation of this plane? That is what we are going to really work on. Okay, what will be your strategy? Just as long as we know the principle, the calculation will be actually straightforward. So, anyone who can tell us how we can approach this problem? Any suggestion? To come up with the equation of the plane, what do we need?
2 lines and a point, or 2 vectors.
Yeah, 2 vectors. If we get on the plane and the point, then we will be really fine. So can we come up with 2 vectors?
Use the slope of the line. Yeah.
Very good. Actually, thank you. If you look at this, actually the direction vector for the line, you remember when we actually work with the equation of a plane, a line, I'm sorry, the vector equation of a line, we have a direction vector and the initial vector, and then the position vector r is going to be the scalar multiple of this one. That's what we did. So in this case, actually the direction vector for us is the coefficient of t, which is 2, -3, and -1. We have that. And by the way, this equation is has actually a point on the line. Let's say this one, we call it Q. Point Q has a coordinate 1, 2, and 3. These points belong to this one. Then now what happened? I have one vector already here, and I can find another vector, PQ, for example. And then I can take the dot product of the two. And let us call this vector PQ. Actually, from 1, you subtract 1, it is going to be 0. And then from 2, you subtract 6, it is -4. By the way, you can do it the other way around also. And from 4, you subtract 3, you get 1. So that is what I have. The point PQ 0, 4. This is -1 because from 3 I mix up. It has to be -1. Am I right? All right. Then now let us take the cross product to find the normal vector. And it's not unit normal, just a normal vector. That means PQ is crossed with the vector V, or this one. And that is I, J, and K. And PQ is 0, -4, -1. and the direction vector 2, -3, -1, and we can really come up with this vector, and that will give me actually, okay, -4 times -1 is 4, and this is also 3. 4 minus 3 is 1. That is I. And for j, this is 0, and minus -2 is 2. That is 2j. But there is a negative, so negative 2j, because the middle has to be negative. And for k, this is 0, and this is -8, and it will be positive 8k. So that is what we have. And if you want to write it in a component form, that is 1, -2, and 8. Then equation of a plane, as you know, it is actually a into x minus x sub 0 plus b into y minus y sub 0 plus c into z minus z sub 0, where a, b, c are this. All right. Then now, and the point that we are given is actually this one, P. You can use that. But if we use this one, is it going to be wrong? No, it's not going to be wrong. You can use also Q. That's fine. But when at the very beginning, when you put it, it will be a little bit different. But later on, when you simplify and write it in standard form, it will be fine. So 1 into x minus 1 minus 2 and y minus 6 and plus 8 z minus 4 equals 0. Well, then this is x minus 1 minus 2y plus 12 plus 8z minus 32 equal to 0. So x minus 2y plus 8z equals, now this is okay, 12, this is 20, and by the way, this is 1. I don't know why I put it to 2, equals 21. And that is the equation of the plane. Okay, is it clear, guys, what we have done? So when you work on this problem on the test or something like that, try to really realize what is happening. Okay, the last concept that we are going to really see is torque. The application of cross product is really finding torque. When we turn a bolt by applying a force F to the wrench, the torque or the moment we produce act along the axis of the bolt to drive the bolt forward using this right-hand rule, actually, tightening it and untightening it. So the magnitude of the torque depends on how far the wrench is, the force is applied, and how much of the force is perpendicular to the wrench. Why? Because let me show you. Cross product will form actually the angle between them has to be like this. So if this is the radius and the force is already applying like this one, then what happens? The angle between them is 90 degrees. So sine of 90 degree is 1. That is, then the magnitude of the force multiplied by the magnitude of the radius will be. But if you really put it like this one, then what happens? If the force is acting in this direction, then the force that is really acting is going to be the y component of this vector F. because the x component is really parallel to it, and when two vectors are parallel, their cross product is going to be 0. And if f is actually acting like this one parallelly, or in this direction, it doesn't matter, the torque is going to be 0. Makes sense from this pictorial presentation? All right, so it represents by Greek letter tau and r cross f, which is equal to the magnitude of r multiplied with the magnitude of f times the angle of sine theta. That is what we have to really work on for. All right, so now what I'm going to do is I'll give you example, which is really very simple, and we will work with those. Okay, very late with my notes. Sorry, here it is. Work we have done already. Okay. Okay. Here is example, and I want you work on this. Find the torque around the pivots shown in the following diagram. Okay, the force has a magnitude of 7 Newton, and the radius has 25 centimeter. By the way, torque is actually measured in Newton meter, the radius. So be careful, this is centimeter. So if you have your answer, actually type it on chat. Thank you.
The pivot is the dot, not the tip of the position vector.
This is the dot. And remember one thing, when we do cross product, what do? Actually, the force and so on, they are acting on the bolt. Yes? If the force is really applied here, and we have the radius, what we have to do is we have to shift it on the bolt because the acting is over there, yes? With a certain degree. And that is what you have to do. Did I answer your question?
Yeah, yes.
Okay. So what we are going to do is, here is actually direct using the formula. All right. So I wish I may edit 30 degree. It will be life easier because sine of 30 degrees 1/2. But we have decimal, then 7 times 0.25 because in 1 meter we have 100 centimeters, so 25 centimeters is 1/4 of a meter, and then multiply by sine of, that is what we get. Now, actually, to hone your curiosity, I'm going to give you this problem, guys. His question is really a valid question, and I'm going to give you this problem and do that. By the way, is it clear, this one? So it's straightforward, then you can handle it, yes? All right, so let's move on. Here it is now. Find the torque around a pivot. Look, the pivot is here, the head of the wrench or something like that. I mean the screw. And as shown in the following diagram, actually the force is acting this way and the radius is 50 centimeter. What is the work done? I mean, what is the torque? Okay, so our work will be like this. Tau equals the norm of R, norm of F, sine of theta. That means 50 centimeters is 0.5 meter, and you have 12 Newton, and sine of 160 degree. Am I right?
Don't we usually use theta as the angle between the two vectors when their tails are connected?
Very good. That's it. So this is technically what? Wrong. So what we have to do is remember about vector. Vector, what we need to know is about it is magnitude and the direction and not location. So we can translate this vector and bring it over here. Parallel vector. And this is our F, vector F. And then now, remember, if we extend this line, this angle and this angle are the same. This is 160 degree. Do we all agree? Therefore, what is our theta equals?
20 degrees.
That's it. So tau equals actually 0.5 multiplied by 12 multiplied by sine of 20 degree. That is what we have to do. And that is how our answer is going to be achieved. So your answer has to be 2.05 Newton meter. And by the way, this one, if you want also, if you are interested in, you can write it in a component form by multiplying it. The I component is going to be cosine of theta. The j component is going to be sine of theta of that is component, and really translate parallel to the R. Okay, and use the cross product. You can do that. So to reflect this one, I will give you one more example, and this will conclude. Here it is. A 20-inch wrench is at an angle of 30 degrees with the ground. A force of 40 pounds that makes an angle of 45 degrees with the wrench turns the wrench. Find the torque.
Do we assume that the 45-degree angle between the force and the wrench acts in the same plane as the wrench?
Yes, that's it. Yeah, always when you are acting, it was going to be on the same plane. Yes.
Thank you.
And by the way, if you have really one line over here and the other line over here, okay, it creates one plane. But if you move this one and bring it here, you are going to have another. So anyways, two actually parallel lines are creating unique actually plane wherever it is. Okay, is that your question?
Yes, thank you.
Okay. Okay, always when you do the problem, try to do the picture randomly. For example, this is our actually radius r, and this magnitude is really 20. And then this is really forming what? With the horizontal 20 degrees, that's given. You guys agree? And then now what happened? Again, you have a force which is really creating, makes an angle of 45 degree with the range. This is the range, and it has to create 45 degree. And let us really put it this way. And this is okay, 45 degree. And then now, this is actually F equals 40 pounds. And then now you have to do the force. So how do I apply this? Guys, how do I?
I'd argue that the angle that the wrench makes with the ground is irrelevant. We can use the definition of the cross product using the magnitudes of the force and the radius and the angle between them.
Why not? It is why it is not relevant.
I mean, we're given the angle between the force and the radius vector, and that's what we need.
Well, if you are really reflecting it here and you are rotating it with this one, then what we are going to do is technically what happened. This angle, the force that you are given with the horizontal, is going to be that important. Okay, if you are doing this one and find the magnitude, that's fine. But now, you can really create this force and magnitude, and you can really create 45 degree. And yes, it is really relevant, and you can really multiply that. Very good. Yeah, because there is the angle between them, and this is it. You have the magnitude here, magnitude of this one, and multiply this by 45 degree. You'll find that. But suppose I'm doing it in a component form. What do? If I try to make cross product as actually of two vectors by component, what do?
You can make a 3x3 matrix with the two vectors, and
that means how then? Very good. That's it. 3x3 matrix. Let's say this is y and this is x for simplicity, and this is z. Then what do? This time we have to be careful. when we do 3x3 matrix, then this plays significant role, okay? Because the I component, it is parallel to the x-axis, the xy plane, and the y component parallel to the y-axis, and the z component, it has to be parallel to this one. But since we are given the magnitude in this case, yes, the easy way will be what? Yeah, 20 multiplied by 40 multiplied by radical of 2 over 2, and that's it. But if you are making it the component form, then what you are going to do is, okay, the R will have a component of 20 multiplied by cosine of theta, and that is I, and 20 multiplied by sine of theta, that means sine of 20. I make it 20, 20 in both. Okay, 30-degree angle, by the way, here. That's 30-degree angle. I'm sorry. Okay, theta, that means 30-degree angle. And 20 times sine of 30 degree. And plus the z component is going to be 0, k. Is it clear, guys? And then the f component. This time, look, you have 30 degree and you have 45 degrees, that is 75 degree. So 40 cosine of 75 degree, I plus 40.
I think you got the J and the K components mixed up.
Why?
Based on how you labeled the axes.
The axis, yeah, okay, you're right. Actually, the drawing I'm trying to bring it. Actually, let me make it this one Y and this is X. That's fine. But based on that, I mix it up. You're right. But for simplicity, assume that I draw it on this side. Okay. All right. Hold on. No. I can trick it actually. This is my X, and this is my Y. I am using right hand rule. This is Y and this is Z. How about now? Is it fixed? X, Y, Z. Still, we can really do it on that direction. Okay. I turn it around. Still, we are following right hand rule. Okay, 40, 75, and sine of 75 degree J plus 0K. And if you do these matrices and the determinant and find the magnitude and this one, you will still get the same answer. The reason I'm bringing up this one is, yeah, when you are given simply the magnitude and the angle between them, this angle is really irrelevant. Just do it. But if you go the long way, there are sometimes we are going to be required actually to find the component form and do the cross product. This is how you guys are going to approach it. In both cases, you will get the same result. All right. So can you check it at home because we are running out of time?
Yes.
Okay. Hopefully, this will help to really review your vector operations and their applications. Actually, in the strength of field and so on, we are going to see them later. And next week, we are going to work with multivariable functions because if we know how to differentiate and integrate, we can, of real valued function, we'll do the same thing with vector valued function. It is the extension is will be parametric form. Actually, the vector has a component, and those components are x component, y component, and z component, and they are parameters. So we know how to work with parametric curves of multivariable, and that skill will be translated into it. Thank you, and I will see you Monday.
Thanks.
Take care.
Yeah.